Hello guys, I welcome you all for the today's session. Today's session is about the curve fitting by the method of least square. So before moving into the contents, let me introduce myself. I am Lakshmi Vaibhavi NV, currently pursuing BE in BSc AI at SVC. So let's get into the topic, and topic is first of all the curve fitting by the method of least square. Curve fitting is a common technique used in data analysis to find the best fit line on the curve that represents a set of data points. The method of least square is a popular approach to curve fitting that minimizes the sum of the squares of the differences between the observed and the predicted values. In this analysis, we'll compare the different curve fitting algorithms and identify the best practices for the optimal results. So curve fitting is nothing but will find the sum, minimize sum of the squares of the differences between the observed and the predicted values, and by that difference we'll find out which results is the best result or an optimal result. So let us see some facts. Some facts is curve fitting is a process of constructing a curve that best represents the series of data points. It involves finding an equation that describes the relationship between the independent and the dependent variables. So y is equals to f of x, we can call it's in the form of dependent and independent variables. Here it's helpful in finding the suitable relation in the form of y is equals to f of x, where x and y can be ranging from 1 to n and which is called as an observed values. Then y is equals to f of x is called as estimated values, and y is equals to yi minus this capital Y. We'll see into this what is small y and what is capital Y in the problem. Now yi minus y are called as residual or estimate errors. Nothing but a difference, I could say. So the next thing is methods of fitting methods. So here then we have three methods: fitting of a straight line, then fitting of the curve a is equal y is equals to x power b, then fitting of a second degree parabola quadratic equation y is equals to x square plus bx plus c. Then the next thing is how to do this, means steps of working procedures. So define a model function that describes the relationship between the independent variables and dependent variables. So what we are going to do, we are going to write down the normal equations appropriate to the curve of the best fit. Then the second thing is choose an appropriate objective function that measures the difference between the observed values and the predicted values of the model function. So after to find out this observed values and the predicted value difference, we are going to prepare relevant table and find all the summations present in the normal equations. Then the third thing is minimize the objective functions to find the best fitting curve, and this can be done by using calculus or the numerical optimization techniques. So we find the parameters by solving the system of the equation. We find the parameters by solving the systems of the equation and substitute in y is equals to f of x, which being the curve of the best fit. Then the fourth thing is if the given value is more than if it's beyond 100 or 200, we are using a logarithm to minimize in the smaller range. Now let's look into the first approach. The first thing is fitting of a straight line y is equals to x plus b. When fitting a straight line to a set of data points, the objective function used in a least square method is the sum of the squared vertical distances between the data points and a line. This approach is appropriate when the relationship between the variables can be modeled as a linear function. So in the question they are going to tell us how which type we are going to fit. Here first thing is fitting of a straight line when the equation is y is equals to x plus b. Then we are going to use this approach. So to make out this, the first thing is we need to know about the normal equations of a straight line. So for the straight line, to substitute all this, we need all these values: summation y, then summation xy, then summation y is equals to a summation x plus b, then summation xy is equals to a into summation x square plus b into summation x. Now let's see a problem here. See, the first thing is fit a straight line y is equals to x plus b. It is a simple problem I have taken here. So according to the formula, what and all we have to find out, we need to find out summation x, then summation y, summation xy, then summation x square. Once we are done with finding out all the summations, the next thing is just we are going to substitute in their positions. Then we are going to find out the constants like a and b. See, we have got with the summations. Summation y is 40 and summation xy is 365. Summation x is 56, b, then b, a and b we need to find out by these equations. So once we are done with finding out the equations, values of a and b, the next thing is we are going to substitute in the equation y is equal to x plus b. So this is the equation we have got. The second approach is fitting of the curve in the form y is equal to x power b. This is nothing but exponential curve form. An exponential curve is a mathematical function that grows or reduces exponentially. It can be represented by the equation y is equal to x power b, where a and b are constant and x is an independent variable. So we'll look into this in the problem. The first thing is y is equal to x power b. Have taken here y is equal to x power b, but in a problem have taken v is equal to at power b, the same form. And as I said, when the values are reaching beyond 100, we are going to use a logarithmic or ln here. So now b is equal to a into t power b. By using a logarithmic, we can v is equal to x power b. Then we can write it as log b is equal to log a plus b into log v. So log a, the same thing we had used here, where log base e v is a capital V, then log to the base e a is a capital A b, then log t to the base e is a capital T. So the formula is summation v is equal to b into summation capital T plus na, where n is the number of given set of values. Then summation vt is equal to b into summation t square plus a into summation t square. So the next thing is, according to the formula, we need to find out summation v, then summation t capital T. It's not a small t. You have to note down here. So it's like we have taken a ln here, then summation vt and summation t square. Once we are done with all the summations, the next thing is, as we did in the last sum, the same thing we are going to repeat over here. We are going to substitute all these values and then we are going to find out the constants a and b. We can't directly write into the solution because in the equation they had given a small a, but we had found out the capital A. To find out the small a, we are going to take an anti-logarithm here. Then once we are done with finding out our small a, the next thing is substituting in the equation. The equation is what they are given here, v is equal to a into t power b. So v is in the place of a, we have got the value 701.966, t, then in the place of b 0.1709. This is the curve fit for the given equation. The third approach is fitting of a second degree parabola, where y is equals to x square plus bx plus c. A second degree parabola is a type of quadratic equation that creates a curved shape. When graphed, it is defined constants by the equation y is equals to x square plus bx plus c, where a, b and c are constants. In the problem, what is our task is to find out these constants, and we are going to substitute those constants in the equation. We will find out what is the best fit for this equation. To find out this a and b, we have formula like summation y, summation xy, summation x square y. Summation y is equal to a n plus b into summation x plus c into summation x square. Summation xy is equal to a into summation x plus b into summation x square plus c into summation x cube. Then summation x square is equal to a into summation x square plus b into summation x cube. plus c into summation x squared 4. So let's get into the problem. We are with a small problem over here. See, according to the formula, we need to find out summation y, summation x y, summation x square y, then summation x square. See, all the things we had found out here: summation x, summation y, summation x y, summation x square y, then summation x square, x cube, and x power 4. So once we are done with finding out all this summation, our next thing is to substitute those in the summation in the given equation, in the given, I could say, given formula. So once we are done with that thing, the next step is finding out the constants a, b, and c. See, like once we found out these constants a, b, and c, the next thing is we are going to substitute those values in the equation y is equals to ax squared plus bx plus c. So this is the equation we are with: y is equals to minus 0.93 plus 3.25x minus 27 x square. So these are the three approaches to fit a curve. Then next thing is application of the curve fitting. Curve fitting is a wide range of practical applications, including but not limited to the finance, biology, or physics and engineering. It helps in predicting the future trends, making the informed decision, then understanding the complex system. Curve fitting plays a crucial role in data analysis. It helps in understanding the underlying patterns and trends hidden with the data. It enables us to make accurate prediction and extrapolations based on available data. So the one example I could give is by fitting an exponential curve to the observed data of a bacterial colony, we can estimate the growth rate and make up predictions about the future growth. The another example is in civil engineering. Say civil engineering, by establishing the shapes in the curve, we achieve the arches, and arch is a shape that resembles the upside down U, nothing but you can say parabola here. Then in the conclusion, curve fitting by the method of least square fitting, the curves of the form exponential application is a powerful tool in data analysis. Accurate curve fitting enables us to cover the meaningful insights and make informed decision based on the available data. So that's all for today, guys. Thank you.